Welcome back. This is part 2 of the reaction to today's episode. To 2171 with Weinstein, and Terrence Howard on Joe Rogan. Sorry, Eric, I do that so many times. Why's it gotta have both possibilities?
Let's get some whiskey and some ice.
Yes, and then we're going to get into the wave congregation.
I want to show you something, and I wanted to ask your opinion before I forget. There was.
Whoa. Now I'm kind of out of it, like not in the listening. Holy crap, that's fast. Let's go back to normal for now and go back a little bit. Okay. Right to it, because this is 4 hours.
You're an American man. You should be able to do whatever the fuck you want. God damn it.
I'm in Sweden.
And you're in
right
Texas. You're an American man in Texas. This is a free state, sir.
now. What do you have?
We have whiskey.
Oh, I would love one.
That's what we need. We need whiskey. Let's
Yes.
get some whiskey and some ice.
Yes,
to
and
get
then
this
we're going to get into
loosen
the
this
wave
party up.
congregation.
I want to show you something, and I wanted to ask your opinion before I forget. There was a recently, well, I recently found it online, of these two photons that were entangled, and it looks like a yin and a yang. Have you seen this?
No. Yes. No. It's not true. I have seen it out of the corner of my eye. I did not study what caused this.
I had to run it by you because you're probably the only one that I know, other than maybe Terrence, that could understand what the fuck they're saying.
I have a model of it.
Okay.
I do.
And I don't.
I do.
I believe you. I believe you.
Model of it.
So what are they saying? How did they see this? Like this biphoton digital holography? Can someone explain that?
Maybe, but I don't know what those words mean yet.
Okay. Do you know what it means, Terrence? Like how they could see this?
A biphoton. Bi always meaning two, but
Someone got
they're
Michio Kaku on the
examining
phone.
two.
Oh,
Did
no.
they smash them? Are they smashing them together? What's their process of looking
Okay.
at them?
That's a very good question.
And they're using the same interferometer that Michelson Morley experiment, which turned out to be. It turned out that it actually proved there was an ether. There's a
Well,
paper.
there's a
but
way
let's-
in which you're right about the ether, to be blunt.
That's
Just
what I've defined.
listen to
as
this
the
statement
ether.
in the beginning. Look, put the bong down.
Lots of people say there's an ether. Saying there's an ether is not novel. Just to point that out, need to actually understand it, that it's infinitesimal. Need to understand that the universe is composed of an infinite spectrum of particles, all of which function the same, that are seen from different angles for an observer composed of a certain particle within that infinite spectrum of particles, and that the subtler particles approaching infinitesimal also approach infinite abundance and flow about just like photons, but are much more subtle and much more abundant. And these are what is called ether. To just say ether, and then to say Michelson Morley proved it, it didn't prove ether. It actually had no evidence of ether. It just didn't understand ether. It looked parallel to the ground. It basically changed the angle that they were looking, but parallel to the ground without looking with a perpendicular consideration. And so we didn't find it. Because they assumed the ether was stationary. That's an assumption. That's not even true, though, because the ether is subtle. If you think about it, it doesn't make any damn sense. Why would the subtle particles be stationary in a universe of dense systems like Earth, the sun? Which ones move in which? The sun, it kind of sits there, just hanging out. Things around it move. Why? Because they're subtler. Because it's influencing them. And if they're subtle enough, they are really influenced. So they're not just like, I'm going to hang out here for a while. They are off to the races all the time, constantly. And they are themselves the cosmos. So, like, if you could zoom in on them, you would see the largest thing. Not like you would see it, but if you could see it from the right angle, the subtle is the large, and the observers are composed of literally every particle in terms of like this infinite spectrum of iterative fundamental particles. I basically call it atoms, planets, stars, shallograms, iterative fundamental particles. Other things in geology like batholiths that are the same thing, just seen from different angles. So like Earth has a photosphere, it's just called the air glow of the ionosphere. It has solar flares, they're just called sprites. It has a disk called the Van Allen belts. It has rotation and a magnetic field, and then the sun has a disk, and its rotation and magnetic field produces a armed spiral called the heliospheric current sheet, like a galaxy, because it is. It's just seen from a different angle, because in both instances we're using atoms which have a relative mass ratio that leads to how it's seen. It's not like it's a given system is inherently like a star. It depends on the observer's building blocks. So if someone's looking at the sun, but they're composed of larger building blocks, they may be standing on it, calling it a planet. They may be looking through a microscope, calling it an atom. But to them, it is that, but it's not that either, because it's the Earth, for instance, or the sun, or whatever. But it's all things. So, when he says ether and brings it up in, like, it needs more substance. That's my point.
And listen to this. High-dimensional biphoton states are promising resources for quantum applications ranging from high-dimensional quantum communications to quantum imaging. Just that phrase, what fucking percentage of human beings breathing on Earth right now have any idea what any of that means?
I imagine that you have a state in a bosonic Fock space, which is multi-particle. So you've got something in the degree 2.
He didn't ask you to explain it, Eric. He feels obliged, like, well, of course I can. It makes me think of scientists that are like, oh, because I have a degree, I know better. And I'm like, okay, tell me about Mount Grenard. If I ever meet a geologist who's like, look, you haven't learned things, I'll just say, tell me what you know about Mount Grenard. And if they've already heard that that's what I'll say, hopefully they'll at that point agree once they look into it. I'll be like, these things he's saying about it, although maybe they'll just look into it without any reference to my work, which would be just silly of them, but that's, that's people. But the point is not, no one knows everything in their field, so like, you shouldn't feel like you're inadequate or something, like in someone else's eyes, like it's a negative. Oh, he doesn't quite know as much as he puts on, kind of thing. If there's something like, I don't know what this is. I don't know what they're talking about. I mean, like Terrence said, by photon. I don't know if they're doing something with two photons. I mean, it's making a yin yang, so maybe they're two energy levels that are not actually the same. Somehow caused to like be contained in some space where they then eddy, I guess, around one another. That would be cool if there's actually like a electrical, like anode, cathode, positive, negative to the photons manifesting because of different energies that they use that leads to an appearance of a yin yang. I don't know. I have no clue what this is about. It's cool, but it may just be cool in some ways. I mean, obviously, the fact that they can manifest a yin yang is more than just cool. It really points to like something fundamental in how this is interacting is why that's a thing. We can really learn a lot from it. So awesome. I don't know. I don't know what this says. Okay. Anyway. Let's just find out though.
Level of a bosonic Fock space where the two photons were created together. And that's going to be where the entanglement comes from. High dimensional, I don't know what.
He knows he's just saying some shit that Joe is like, I don't know. What the fuck did you just say either? So maybe it's maybe, I don't know. Just saying some shit though. Oh my god, Eric. I hope he's onto something like that I don't appreciate. Pardon me. Because it all sounds kind of, I don't want to say hoity-toity or something. Like too, like a result of a certain demeanor almost.
What it means because I know too many different.
Like a perspective. Yeah. If I use these big words, it's better than if I don't use these big words. And then I sound smarter, but like the objective should be to communicate to everyone, so those words should be really almost restricted to when it's clear the audience is like following to that point. But in just random like appearance, like what just happened, it doesn't actually make any sense unless you already know what he's saying. Maybe you understand, but I just don't think there's anything like fundamentally true to what he's saying. It's just some aspect of reality that is there, has been appreciated in some observations or some way, possibly even observations and then theories that lead to possibilities that are, oh, maybe this, and then those become ideas that are like abstract ideas that are never truly observed but become like cornerstones of what he's saying, and maybe it's kind of more so that, I don't know. But the point is, like, no audience should be expected to have a clue what he just said. Like, I believe that anyone listening to me could understand, maybe not agree with, but could understand what I just said about like the infinite spectrum and what ether is. They could understand it. That's one thing to just do, like blah 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 blah, understandable thing. But to just like, what the fuck did he just say? It's just like a disconnect that leads to like a continued disconnect, because maybe he said something true, no one knows. And since he's like got a platform out there it's not like anyone's resisting it. He's not saying anything he hasn't said before, so he's not like creating some potential of being like canceled or something. So, like, I don't know. I'm done talking now.
I assume it's a term
for
of
now.
art in this area. And what they're saying is, if I can create something that is geographically distributed, but also linked at the point of
Oh, I just realized I've read the whole freaking thing muted. Well, hopefully you've been reading. Oh yeah, I'm kind of doing a good job. These words, I'm reading them. Cool. But I was saying, the one thing I noticed is here we introduce. I don't know why I can't click it. What the hell? Can't even like copy it. Oh my god. Let me just see if I can find this paper maybe on Reese. It's probably our whatever though. It's probably on here. Interferometric imaging of amplitude and phase of spatial by something. Can't really tell what I have written there. By photon states. There we go. There we go. Where is this yin yang then? Let's see. Let's find the yin yang first. Yeah. Image reconstruction. Pumping with a state of a Let's see what they had to say about Figure 5. Shows an example of the potential applications of biphoton digital holography. The unknown pump beam can carry information about an image or be scattered. So it's just an image. It's possible, looking at that this is an image, like a television, that they could have projected anything. They just chose to project a yin-yang symbol. That's what that sounds like. Novel approach for reconstructing, yeah, okay. I might be wrong in my interpretation, but I'm going to move on and say that that is saying they're just projecting an image. They didn't, like, interact light and create a yin-yang. I don't think that's what happened. Like, by just purely shining beams of light together and then creating a yin-yang. Not what happened. They just used an image that kind of captured the minds of some author, yin-yang, that then published whatever we came across that they were looking at before this. Okay.
Like this biphoton digital holography. Can someone explain that? Whiskey. Let's
Yeah.
get some whiskey and some ice.
Yes, and then we're going to get into the wave conjugation.
I want to show you something, and I wanted to ask your opinion before I forget. There was a recently, well, I recently found it online, of these two photons that were entangled, and it looks like a yin and a yang. Have you seen this?
No. Yes. No. It's not true. I have seen it out of the corner of my eye. I did not study what caused this.
I had to run it by you because you're probably the only one that I know other than.
Okay. That paper definitely, whatever, the article that he's referencing definitely presents it that way. Biphoton state. I think biphoton has, it's just like, this is all biphoton too. Or wait, maybe not. Biphoton state. So these are all biphoton state. Or whatever. These are biphoton state, biphoton. Biphoton fields obtained by pumping the crystal with LG modes. Ew. So they're definitely interacting something with light between a reference SPDC state interference between this and a state obtained by a pump beam. So maybe it's saying interference. It's a little, like, the wording is a little hard. Like, it could be like certain things are like coincidence image of interference. So interference between a reference SPDC state and a state obtained by a pump beam with and a state obtained by a pump beam with a shape of a yin-yang symbol. It seems like the interference, it's saying coincident image of interference with the shape of a yin-yang symbol, and this is the interference between these things. Okay, so it's actually producing it. Let's see. SPDC. Spontaneous parametric down conversion. Focus on the specific problem of reconstructing the quantum state and the transverse coordinate basis of two photons emerging from degenerate spontaneous. I don't want to look too long at this. Okay, let's carry on. Looks like it actually is a outcome, though.
Then maybe Terrence, it could understand what the fuck they're saying.
I have a model of it.
Okay.
I do.
I don't.
I do.
I believe you. I believe you.
Model of it.
So what are they saying? How did they see this? Like this biphoton digital holography? Can someone explain that?
Maybe, but I don't know what those words mean yet.
Okay. Do you know what it means, Terrence? Like how they could see this?
A biphoton. Bi always meaning two, but
Someone got
they're
Michio Kaku on the
examining
phone.
two.
Oh, no.
Did they smash them? Are they smashing them together? What's their process of looking at them?
That's a very good question.
And they're using the same interferometer that Michelson Morley experiment, which turned out to be. It turned out that it actually proved there was an ether. There's a paper.
There's a way in which you're right about the ether, to be blunt.
That's
Just
what I've defined.
listen to
as
this
the
statement
ether.
in the beginning. Look, put the bong down and listen to this. High-dimensional biphoton states are promising resources for quantum applications ranging from high-dimensional quantum communications to quantum imaging. Just that phrase. What fucking percentage of human beings breathing on Earth right now have any idea what any of that means?
I imagine that you have a state in a bosonic Fock space, which is multi-particle. So you've got something in the degree 2 level of a bosonic Fock space where the two photons were created together. And that's going to be where the entanglement comes from. High dimensional, I don't know what it means because I know too many different. I assume it's a term of art in this area. And what they're saying is if I can create something that is geographically distributed, but also linked at the point of creation, like if a photon decays into an electron-positron pair, those two are going to be entangled. And if you make a measurement in a quantum sense of one, you seal the fate of the entire system. And so what they're trying to say is, if you want to get jiggy, people always want to talk about faster than light communications by taking an entangled pair and saying that if I do something in one place, I know what happens outside of my light cone. So we can give meaning to these things, and then you have to say, well, it doesn't allow you to create information transfer faster than the speed of light, and you have to be very careful and precise about it. But if you just start getting jiggy, then you start thinking.
You introduce the ether.
Thanks, sir.
So the ether, in part, when I've been here on previous versions of JRE, I talked about vector bundles. And in a certain sense, how do you have a wave without a medium? And the medium was supposed to be this ether. But the medium is actually something called a vector bundle. It's a little bit weird that you're a wave.
No, it's perfect because the vector bundle. Go ahead. I'm not going to.
You're a wave in a medium. And you as a wave don't know that you're a wave and you don't know what medium you live in. And it's funny that you go through life not understanding what you are.
No, but that medium, that luminiferous medium, ether, that Maxwell wrote all of his equations off of, Newton believed that light was propagated on that same medium. The only reason that special relativity came along was because they had misread the results from the Michelson-Morley experiment because it did show a slight change or some drag, but from that point onward, because Einstein's theory of relativity was so easy and it predicted all of the movements of things, they abandoned.
They had a bad idea of what the ether was going to be, and
maybe it was one of the straws on the back of the camel, but the straw that broke the back of the camel was the observation of Mercury and its differences from prediction of Newton and trying to account for it, and where Einstein presented some alternative that fit the observation but wasn't really true. Just fit the like, oh, look, it fit. Guys, maybe we're not accounting for it fit. Dude, you know there was a time when Newton's laws mattered? People were like, that makes sense. It's not really Newton's law. Logic mattered. People just said, that makes sense. Logic prevailed until it didn't. And someone was like, fuck logic. How about this? It explains that. Oh, he's brilliant. Wow, he's an Einstein. Like, dudes, have you seen his interviews? Have you seen him public speak? Like, who is this? What is going on? That's what happens when I look at those. It's like, is this the same person that they're selling us? What the?
Special
Because they thought
relativity
it was
said,
steel.
yeah, in
They
a certain
thought it was-
sense. And what you are trying to say, the way I interpret it, again, and I don't know if I'm right if we don't do the work, is, hey, the spiritual successor to the idea of the ether exists. And that
Yes.
thing has properties. And if you say, if I put a vector bundle on top of a Lorentzian manifold, then you don't have a contradiction. And if you call that the ether, that's more or less what we work with. And then we do this weird thing where we say, well, they used to think the ether existed and it didn't, ha ha ha. And that's not really...
Because that's when they said that.
He's trying to just call something in his, like, model the ether to fit it into his worldview, but that doesn't describe the ether. You need to view the ether as it is, which is not the worldview he just tried to put it in. It's just smaller and smaller particles. Ad infinitum, there is no end, approaching zero, to the point where they are indistinguishable therefrom, utter nothingness, and in such abundance that their quantity is indistinguishable from infinite. That is ether. And, like, with a gradient, that's kind of like approaches more gross, larger, denser systems like planets. Like, that's still ether. Earth is still ether. Stars are still ether. It's just they're so large that for us as observers composed of atoms, atoms kind of set the upper boundary to what's small. Anything larger than atoms is big. Like a rock, a planet, big. Big enough to hold in our hands and be like, that's big. Or bigger. Like, that's a frickin' star, man. That's a black hole. But subtler than atoms very quickly approaches nothingness to an observer composed of a certain building block. That is ether. Is not some other description. You don't want to put it in some other way because that doesn't capture what it is. Then it's some other paradigm that's just like, see how this is ether, but we'll still view it through this other paradigm and just label it ether. He's trying to label some aspect of his own theory ether without actually describing what it is. It's a flow of particles, just like in the ocean. It's not like to describe it as just a field doesn't capture what ether is. It's particles. Ether is not waves. It is the particles that the waves are composed of. Just like planets and atoms. Atoms are particles. Although, once you start looking at quantum mechanics, you might start to think different, but that's because interpretation has led us awry. If you think in the right paradigm, you can come up with what might be happening instead of some, paradigm shifting new physics, quantum mechanics, classical mechanics, the one based in logic and reason. What a surprise, that one is the true one. It's just the illogical one has usurped the discussion, and the logical one, because the explanations are not immediately apparent because it takes thinking about it, has just not gotten the attention it needed to come to understand what the hell is happening in these experiments. And then we're off to races with quantum mechanics. A century later, we got it still roaming the world, controlling the discussion when it's not true. It's always been classical mechanics. Like, when you make a slit narrow and then put a particle through the slit, it's so close to a physical gradient in mass that it just gets pulled in and it bends. Dependent on its position in the slit, if it's on one side, it bends towards that side. If it's on the other side, it bends towards that side, producing a wave out of all the particles doing this. And then when you put two slits, they interfere with each other. And when you randomly send a single photon through, it doesn't care that it's a single photon. It still goes through. It bends according to its position. Dot. The next one does the same. Bend. Boop. Dot. Wave interference. Not some spectacular wave-particle duality, new physics, we're gonna make shit up now. Colors, what are you guys even talking about? Have you seen a quark? I didn't think so. Calm down with the ruckus. I've seen atoms. It's called a shallogram.
That space was a vacuum, and they realized that space is not
a vacuum.
It's not a vacuum. Yeah. It's not a vacuum.
Do you know how much is going on in that vacuum? It's all going on.
Yes, all of this stuff.
I understand. So this is the thing, which is if you step on this thing the wrong way, everybody laughs and says, ha, 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 he doesn't understand the Michelson-Morley experiment. He doesn't understand why there's no ether. And then we secretly...
Oh, man, maybe not laugh. People don't have to... It's not laugh. It's just a matter of... He didn't. Like... The experiment was just flawed. There are experiments that show light changes in an ether. It's just called magnetic fields in those instances. We don't appreciate what that field is composed of. I wonder, could it be that one thing that we never seen before? Where could it be? There's no evidence of this ether. None anywhere. None. Never mind this magical field that comes radiating out of a physical object and attaches it to some other object. Oh, that's just a field. There ain't no ether. Pfft. Fields, that's what there are. There's just fields. Dude, did you look in the ocean? Would you call that fields? So don't call that fields when it's ether. It's just ether.
At least sneak it back in this. Thank you, John. Cheers.
Cheers, John.
Yeah, cheers.
Do gotta know what it is. I mean, if that's a fact, he is stepping into territory where if he actually says things wrong and like maintains them, it's gonna get pointed out. That's just what happens. Like, if you're not ready for that, I'm ready for that. I say, thank God, finally, the day has come. Free at last, free at last. Thank God Almighty, I'm free at last. That's what I would say. Peace. You guys have fun with that. I got shit to do now, which is not care anymore. I've done my caring. You guys got some catching up to do. You let me know when you're ready. That's how that'll be. When the world ain't pissed off about it. Please? Okay. Alright. Not some... We invited you on. And you said... Get the fuck out of here. No thanks. You fucking... That's how that people are, though.
Look at these professional spherical cubes.
Yeah, they're cool, right? Brown ice cubes.
Now I can have a conversation.
Oh, yeah, no. So...
Mental freedom in a glass.
So
or in prison.
If you're careful about it, it makes sense. If you're not careful about it, the whole thing blows up in your face.
And the reason that I speak about the ether, all of the wave conjugations, all of my patents have been defining different aspects of the ether. I believe that I've defined the electric side, the plasmoid side, and I believe that I've defined the magnetic side.
This is not how patents work, dude. You don't do theory through patents. It's kind of reminiscent of in the first reaction part, where my reaction to the patent, that he said a well thought out, like it's just some kind of sugar coating of an idea to make it look better, and then present it with this coating that has this appearance to it. And he keeps like pointing it out, my X patents, blah, blah, 97 patents on this, and but one says it's a toy that was talked about in the last one, so like, you know, you call it a toy in a patent, they're probably gonna look at it as if it's a toy and be a little more lenient on letting it go through. I'm just thinking, you know, this is a toy, who gives a shit? Just some silly thing that sounds a little bit like that other one, but hey, you know, you put some words in to make it sound different enough. Go ahead, buddy. Fly your toy. And then he's on Joe Rogan like, I got patents. That's what I'm just like, dude. Not good. Not good.
Side and the Constitution between them. I mean, that's what I want to show.
I want to get to that.
Let's go back to the flower.
Oh, but before you go from that other spot, if you look at that picture again of those two photons interacting, it looks like it's at the center of what would typically be a whirlpool. This is like the very center of a whirlpool. So they've got them moving right by each other, or in creating that vortice, that natural vortice. That's what they took the picture of. They looked directly down at something being at two lights moving a fluid.
And they described how they take the picture. It's so complicated. Jamie, go back to where it was, where they were explaining the what they use. Here it is. Here we introduce biphoton digital holography in analogy to off-axis digital holography, where we coincidence imaging of the superposition of an unknown state with a reference state is used to perform quantum state tomography. What the fuck?
See, but that's because of the uncertainty and Schrodinger, all of that. But if you were able, because they start.
That was just some buzzwords. I feel like that's not reasonable. It's kind of like they're saying ether. It's just a buzzword. You gotta describe it. And if you're not describing it as what I've described it, because that's just what it is, not because of me. Nothing to do with me. That's just what it is. That just means you don't understand the ether. Maybe you appreciate its presence, but you don't understand it actually mechanics. How it is. Once that picture is there, it leads to other things like gravity, magnetic fields, and you can kind of just visually, mentally conceptualize an image like in your head the things in ways that are just you can't do with an approximate understanding. It leads to these almost like computer modelings of current flows and things that you can just be like, that's how that would be, and kind of just picture it in an ether setting, though, while accounting for like that there's a gradient. So like some particles are subtler than others. That there's also a gradient in the velocity of these particles. Some approach infinite more than others. The subtler they are, the more they approach an infinite velocity for a given observer, which is why gravity is instantaneous, although people try to link it to the speed of light lately. I don't know what's going on with that. It seems little just ridiculous at this point.
Started off trying to predict an electron cloud and find a little particle inside of it and couldn't predict it. So all these uncertainties and probabilities came out, but they were doing things on a two-dimensional basis. That's what I believe that I've figured out with the wave conjugations, because they talk about they show the pieces of hyperbolic space to where you don't have to go through all these unnecessary steps to reach it.
I'm just so happy that someone's doing something like this. I'm so happy that we can talk about it. I don't think most people have any understanding of what's going on at the highest levels of this kind of science, because it's so damn fascinating. These people are finding the very building blocks of the universe and studying them. It's fascinating.
But this is a bit up from that. I mean, the tomography is like how we assemble a picture of you when we do an NMR or a CAT scan. We have this thing called the radon transform, where we send waves through your body, and then we assemble a picture of what's inside your body, reconstructing it based on sending probes in and measuring.
Think a rock just randomly got like this. According to modern science, this fossil was just captured in a material that eroded like this. Like this. According to modern science, it eroded like this in a river. Does that look eroded in a river? How about does that look eroded in a river? Definitely seen, I'm looking kind of for yin-yang ones that I've come across. I don't know if I labeled any. I mean, this... Let's see. Ammonite. This is very important. I'm not just randomly talking about this. What the fuck is he doing? People are like, what the fuck is this? It's very important to the subject matter. This is no fossil. This is etched by current flows. Ammonite. But recessive ammonite. Lobe. So before I go back, I'll just kind of show you where we're looking. This is maybe a little questionable, maybe more so over here. And then beyond it, though, at its center is an exit point where the current came out of the stone, ran into surrounding current. Let me just make sure you guys can see this all. Ran into surrounding current, which then pushed it back into the surface over here, though. So it went out, off surface, back, return, cut in a eddy, though. So it comes out from an eddy-like shape, so in an eddy, comes over here, in an eddy, cuts over here, then continues where it interacts with basically what I call a high current. So like a lot of current is generally flowing in that direction, producing a pressure path. So it's like a high current pressure path produces resistance, so that as this comes off and back, runs in here, runs into the resistance of a high current pressure path, which is happens more than once, and like that's part of the process. Where like right here, the center of the boundary over here, from the center is a high current pressure path. And then it goes over here, runs into this high current pressure path, and builds an eddy behind it, which this one's behind, like it runs up to where this is. I mean, can argue if these are, like, every detail is valid or whatever. But the point is, then it continues, builds another eddy, another eddy, another eddy, which maybe this could be further down, more towards here, might point towards that, like some relationship to that point specifically that relates to this point, where this one maybe relates more to over here and over here. And then it continues, though, over here, where then it fractal eddy bridging both directions. So what happens over here is it goes in, cuts in, goes up and past here, where another current pushes it back, because this is part of a larger ammonite. So we've got this ammonite, but it's because an ammonite is an eddy. An eddy is flowing here, cutting into this rock, an eddy of water cutting into this rock that it is also transporting the particles of. So it's not just like a hard rock, it's a malleable fluid material that's rock shaped, but has current flow through it and under pressure, so it's not just like disintegrating. Cutting it and transporting certain materials, so that then it leads to this pyrite, where the pyrite extends over here just beyond. So it's not part of this one. Like this pyrite, which tends to be related to like the ammonite more so. Like notice it's contained up here largely. But then down here, it extends over in this little segment, which gives this piece an overall shape more like this piece down here. So notice down here, we've got this like rainbow thing, and then the rainbow opposite direction thing, where it's releasing current from the interior of the rock that was getting into it here, coming out of the rock, as well as this way, just going more so this way, and creating an eddy here, like this way, along this section, probably coming out this way and running into resistance to eddy here along this plane, but continuing the resistance being another eddy over here that had like a nucleus here that was producing an ammonite boundary over here, which was forming an eddy because this other current was coming back, ran in here, and resistance was here from that current. So it held a boundary, other resistances over there as well that relate to other things. And it formed this path, though, where then it runs into, because it's in an eddy, there's a current coming the other way towards the backside that shoves the current as it goes this way over top the edge. As it goes atop this edge, this face, it goes from a region where current is pushing it into it to above where a current is flowing the opposite direction and shoves it the other way. So it returns the other way around this chakra, literally turns around making a chakra, comes back down this way, where then interacts over here, here, and through this way. But some of this current, this region interacts with this region, which then between them produces this region, which then itself has a boundary that goes up this way, over here, over this way, or over like this way. There's kind of like a region that this is around, and that where this one, if you look up here, kind of has like a circle around it. It goes across here, across right there, and then up through this region especially, and then across here. That surrounds this, so there's a larger eddy that was happening there, centered on this, but just pushing this boundary in. Point is, this is how reality is.
How the system responds. We could get through this, but I can tell you that I can't read this instantly. It's gonna, that would take me 15 minutes with looking things up.
See, and the things that I wanted.
I was just going to say, it's just an unbelievably fascinating time that we can actually look at these quantum entangled photons like that and just see it.
But we need to do a better job. Look, right now we're in a crisis where no one knows what's true. Nobody knows who's full of shit. Nobody knows where they can trust, what they can trust, who they can trust. And one of the things that actually, moved me to come and to reach out to Joe is that by default, I think, I've addressed the National Academy of Sciences 4 times, I think, because they were lying and I caught them. And so they wanted to know how much I knew about their lie. It's weird to think that this little studio, in a weird way, is one of the rivals of universities when we don't know what's going on at Harvard. As you have recently seen, we don't kick out plagiarists. We don't check what's going on at the National Institute of Health. And so it's very strange that this table is one of the last things that is trusted by many people. And that's one of the reasons I'm here, which is
I purposely mouthed here in my bedroom because he ain't heard about what been going on up in here, and I ain't talking about them things. Talking about them other things, them things that been going on up in here that are. Cause then the debate, all this discussion, people will start to recognize it's true. It's not a question. They'll be like, holy sh... It's not even a question. Dude's on point.
People have a chance to see people in conversation about things. And, you screw up, but the conversation's recorded and we all go on. People have a chance to see what's coming out. If we can go back to the flower of life, I can try to...
I love that. But like with the flower, all of these things, I went up to Oxford 8 years ago and tried to present them there to be examined. They didn't want to take me seriously.
Because you keep coming at it
because
in the way
one
that you're
times
doing.
one, when I said the one times one, but like I said, that was a metaphor to say
Terrence, nobody hears it that
something's
way.
wrong, something's wrong, but they know something's wrong with the math. It's not adding up.
You bring up renormalization theory a lot.
Right.
Renormalization theory is a way of saying we know that we're working with math that's...
He didn't just let him tell him. Because that's resistance to like someone clarifying it. I understand, but at the same time, he made a valid statement, so no need to resist.
It's wrong. And on the other hand, we have a way of working with math that's wrong, even though we know it's wrong. If you have an error of a particular kind, and you can find an expression with the same error that's different in the denominator, sometimes you can cancel the part that's wrong because you introduced it twice. So introducing two problems is better than having only one problem because you have the opportunity to have one problem kill another. So in this
is there a potential future where human beings, through whatever means, develop a superior method of mathematics that doesn't have a problem with the number 2, that doesn't have all these issues that we're talking about?
Well, that's what I think I've done with my wave conjugations. It solves all of those problems. That's what I can't wait to talk about it.
Okay.
It solves all the problems. So this is, like we said, we start with the tetrient. Now, I believe...
No, we haven't gotten to the tetrient.
You're just talking about the flower.
Look, you have a story.
Yes.
And by doing the Nantucket sleigh ride, you lose everybody like me because nobody thinks it's real. And what parts of it are real, and what parts of it are wrong, and what parts can be improved, and what parts should be improved, and how important it is never going to get adjudicated.
Beautiful.
So you start off with the flower of life. It's a very coherent story that this thing is found all over the world. I learned from this. I didn't understand how widespread it was. I didn't know that there was a mystery of it. I know something about sacred geometry as a kind of spiritual geometric thing. We can talk about it later. Terrence has a couple of ideas, maybe 3. One of which is maybe it's not about that flower of life because that's in a 2-dimensional plane. Maybe that is a shadow cast by something in higher dimensions. And it's a cryptic message from an advanced consciousness that will open its secrets when we finally understand it. Now, there was something, for example, called the Antikythera mechanism, which is a bunch of gears found by this Greek island of Antikythera. And famously, it was just in the Athens Museum.
It predicts the constellations.
We didn't know that. There were 2 cats who really focused on it. One was named Derek de Sola Price, and the other was Richard Feynman. And they were obsessed with it. And it turned out that thing completely rewrote our understanding of how much ancient wisdom and knowledge there was, because this was a mechanical calculator for understanding the positions of celestial objects, far more advanced than we had any idea was possible.
Yeah.
So if you want an analogy, in part, I'm trying to steelman you. We have a situation in which the Antikythera mechanism gives you a possible example of what the flower of life might be. It might be a cryptic instruction. A different version of this, the Kerala School of Astronomy, which was a religious school in the south of India, in the west coast of India, more or less worked out.
Look at that beautiful thing.
Well, that's a reconstruction.
Yeah.
That thing.
Yeah, that's the real one.
Yeah.
But I mean, when you look at the actual reconstruction, what they think it actually looks like.
If we,
fascinating.
Can we get the video for the reconstruction?
Yes.
It's mind-blowing.
What year was this that they believe it was constructed? 2,000 years ago?
This is when they still believe in the
ago.
Ptolemaic example of the world, but this doesn't seem to follow Ptolemaic equations, those 39 equations from
Well, it's, because of so many different factors, war, natural disasters, there's been a lot of moments in history where shit got lost. Just the pyramids are the best example of that, right? Like, what the fuck did they do? We don't really know. We don't really know how they did it.
Well, we're just talking about Werner Herzog.
Yes.
Werner Herzog created an entire film, Fitzgeraldo, just to test his theory about how to move heavy objects over a mountain. Right? So he wrote an entertainment to test an engineering theory. And this idea about entertainers not being scientists or engineers is just total bunk. Like, Werner Herzog is an engineer. And
he's also an actor in a cheeseball movie. He was in Reacher with Tom Cruise. He was the bad guy.
It gives that guy an opportunity to cut off his finger or something.
Hilarious.
It's hilarious.
He's good, though.
Hedy Lamarr, famous for spread spectrum technology. So I
invented
don't find
Wi-Fi, essentially.
That's one of the reasons I believe that we listen to people who have things to say. So if we go back to the flower of life. So
say that again, Eric. I didn't hear you. I could have sworn that you ignored me for the last however long. I don't know. Maybe I'm mistaken. Says, therefore, when it's advantageous, do it. Don't do it if it's not to your own personal advantage, at least perceivable. Well, this circumstance is in his advantage. He gets to kind of partake. He's on Joe Rogan. This is a big deal to be on here. This thing's blown up since it happened. This is already getting a lot of attention. Sure that's not why? Sure that what he just said is the truth? Or that's why? Which one do you think it is? Eric, I'm asking you I'm asking the world for your sake.
So Terrence has a couple of ideas, one of which is this is the shadow. Another of which is that once you go into higher dimensions, you should be thinking in... so you should be thinking of these curvilinear structures, and then instead of focusing on the spheres, you should focus on the areas in between, the voids. And in crystallography, you might call this the interstitial voids. So there's several ideas that this confused, by the way, Neil deGrasse Tyson, because he said, I don't know where these shapes come from, but they are beautiful. That was like the faint praise that he ends his critique with. So what Terrence is doing here is he's saying, look, the circles are cross-sections of spheres, and the spheres have to be placed in very precise places to generate what Terrence is going to start talking about as wave conjugations. And he has different ways that spheres run into each other. Then he says something very cryptic, where he says, if you drop a
pebble
in the center of a spherical lake, circularly symmetric lake, the wave will radiate out until it hits the wall, the shore, and then it will radiate back. And so he's talking about this, and he says wave conjugations, and wave conjugation didn't call up anything directly when I heard him say it.
They would call it a phase conjugation.
Well, or they would talk about, the conjugate wave coming back. If you do something like a garden hose that's affixed to the wall, it'll hit the wall and come back or something. So what Terrence is talking about is the idea, and you could do this, where we could drop, like, let's say 6 stones in precise places in water, and then, using super slow-mo, watch what happens as these waves in precisely placed places run into each other. Because really what physics is waves in collision.
And they're going to create a particular cymatics, which is going to show the harmonic points where matter and all of those things occur. That's the predictive
I'm not
nature.
going there yet.
Okay.
So then what Terrence does is he has in Blender some means of bringing up platonic solids that are not the usual. So I bought some of these platonic solids from Amazon, and you see that they're all extremely Cartesian. They're made up of flat faces, our best attempt to do flat faces. Terrence says, I don't think that has to be the case. If you generate these things from this pattern, and he focuses on the tetrahedron and an octahedral structure.
Can you go up, Jamie, please, so we can see it as from that side perspective of it? Yeah, go around.
Okay, so what that is a curvilinear tetrahedron with spherical, and it's not actually hyperbolic. Those are going to be positive curvature, not negative curvature. No, that's going to be positive curvature.
Compressing in.
Yeah, I think it's positive curvature because those are going to be parts of spheres.
The spheres are interacting.
Yes,
pushing
but negative
inside
curvature would be more like a Pringles chip, where the principal axis of curvature went in different directions. So I think it's not negative curvature.
So this isn't the negative space between 4 bubbles?
No, what you mean by negative space, negative curvature and negative space are different concepts. So the word negative is appearing twice, and that's why we're confused. Again, there are a million of these gotchas where you're not.
Can you describe the difference between the two?
Sure. If I take the tip of my nose, that's going to be positive curvature because I've got one
extending out.
One curve going in one direction, the other is going in. They're curved in the same direction. On the other hand, if you look at like the crease of my nose, that's going to be negative curvature because I've got one that's going like this and another that's going like that. Jamie, is it possible to take a look at a monkey saddle? So that would be negatively curved, right? Because you'd have things going in opposite directions.
Those are cool.
Okay, maybe I was half paying attention. Maybe it's possible. I was singing Les Mis. Do you hear?
See.
Yeah.
That looked a little comfortable.
Okay, so negative curvature is
a model of that.
Yeah, so negative curvature would be what we would be talking about with like hyperbolic space. And spherical curvature would be what we were talking about with the inside of those curvilinear triangles on his. So he's making, again, I don't see this isn't where I think it's worth, saying he's wrong. He just doesn't know the language and doesn't know that there's a formalization of it. Now, if you take, so the other structure that he keeps running across is an octahedral curvilinear. I don't know. It's not really a platonic solid because it's not flat.
If you go and push, you have to push on the jewel on the side, Jamie. If you go to the side of the thing, press on that jewel, and then go to that blue on that right. That blue, yep. And then you get where 8 bubbles.
So now what he's doing is he's saying, if I have 8 bubbles, and these bubbles, each face of this object, this octahedral object, he's taking a sort of curvilinear triangle on a sphere, and he's imagining that these things are all sort of racing towards each other. And how would you generate? No. Don't. If you put those two in, he's going to go into a different world.
No.
So if we take
you can just tap on each one of those tetrians. Just tap it, it'll go away. Tap it, it'll go away.
Now, how would you generate? So Neil doesn't know where this comes from, right? Now, the way in which you would do this, I believe, is that you would take a. Let me think about how you do this. You take the eight
tetrian.
No. You take the 8 vertices of a cube, and you'd put a sphere at each one, a small sphere. So imagine that you had a vertex at 1, 1, 1 in 3-dimensional space, and then you had another vertex where all of the vertices are going to have either 1s or negative 1s. So you have 8 possibilities. So you could have negative 1, 1, 1, or 1, negative 1, etc. You allow those spheres to increase to a size of square root of 2 radius, and that will close off all of the means of escape, leaving a cavity in the center of your cube. And that cube will have an octahedral cavity that looks like this. That's how I think you generated the sucker.
I actually generated this by putting 8 of the pieces together. I took 8 of those triangular pieces together, and I put them together. They basically became the basis of 2 tetrians.
Yeah.
You know, which this would be seen as a neutron. And the interesting thing about this piece right here is nature always makes things in pairs, and they're always balanced. This doesn't exist. This exists only as a result of a pressure condition, a higher pressure condition. Jamie, if you go to that last blue, tap that last blue on. Yeah, pass not the last blue. Go around one more time. That one right there. That Huntian only exists as a result of the 8 pressure conditions created. Hold on, you'll appreciate this. Tap on that the Huntian in the middle. No, not that one. Damn it, you got to start it again. You can hit that one again, and then tap on tap that. Make that go away. That right there is the pressure condition created from 8 tetrians interacting, and they create that other greater pressure condition. That's the negative space that they generate, but it's a massless area, because the moment that the tetrians disappear, that space goes away and the energy generated disappears. But it's a part of everything in my model.
You're putting a lot of words. Like, first of all, let's just admit that this looks gorgeous.
Pretty cool.
Incredibly cool.
Putting a lot of words. That's what I'm saying. That was a good way to summarize what I was saying earlier. Eric.
Around, Jamie, so they can see it, please.
So, the problem, Terrence, is that you have a desire to go immediately towards what this means, right? And before you get to what it means, people don't even know what it is.
True.
Right? So what I'm going to claim is I've got these 8 rambutans here.
What's a rambutan?
It's like a gorilla testicle. You ever had these?
No, what are they? Is that fruit?
They're
Yeah,
fruit.
it's like
Really
lychees.
good.
Oh, lychees. I've had lychees.
But this is, I think rambut is the Indonesian word for hair.
Where'd you pick those up?
Ranch 99 Market.
It would have got you some flowers, but the light changed.
If I take 8 of these suckers,
Okay.
and I arrange them in a cubical formation, there's going to be one of Terrence's things
In the center.
in the center.
Right.
Except they're going to be 6 holes for the sides of the cube where you can get in. Now, what Terrence is saying is, imagine that these are special magical rambutans. I can't even hold this thing. And that you allow them to grow a little bit bigger so that those holes close off by moving through each other. Imagine that they're made of magical substances. In the center, you're going to get one of his curved linear octahedral structures, which is the thing that he just subtracted off. He calls it the Huntian.
If you tap on the pink right there,
Yeah.
you'll be back to that. The next one next to it. Wow, I shouldn't have done that.
Okay. So what's going on is that, for example,
Thank you.
Neil can't figure out, well, where did this come from? So what it is spheres of radius root 2 at the 8 vertices of a cube passing through each other but closing off an octahedral cavity with positively curved triangles inside.
That's what I needed you for.
Well,
That's just when I needed you most. Thank you.
pretty glamorous. Okay.
Well, can I ask you, Terrence, before we go any further, what was the inspiration for diving into this? Like, what revelation did you have that caused you to start looking at this as a 3D structure and the space inside of it?
They're going to call me crazy again, but when I was 42 and had been kicked out of the world as a result of the allegations, I had another dream. And that same being woke me up and took me back to where I was when I was a child. And I started putting the pieces together, the all shapes
In your dream.
In the dream together. And then I was like, oh, so it's where four forces meet that makes a difference. So when I put four spheres, four circles, I cut four circles out, and I made the all shape. And then when I started adding them together, then I saw the flower of life. I didn't see the flower of life initially. I saw that after when, well, I'll show you the piece.
But the all shape is a different thing. Because in this case, in order to do this, what he did is he said, I'm going to make mathematical spheres. They're going to start to intersect each other, right? And the intersections are going to be ignored because it's made out of fictitious math material until they close off the holes in the cubical lattice structure, leaving octahedral voids with this kind of curvature. To make what he calls the all shape, you do something very different. You'd start off with the tetrahedron, which is distinguished among the 5 Platonic solids as being self-dual. That is, there are 4 vertices and there are 4 faces, and you can interchange faces with vertices. And in fact, I don't know if you guys have these things. You have this?
No. What is it?
So this is an engineering feat. So if you think Platonic solids are old, a guy named Chuck Haberman figured out how to take the self-duality of a tetrahedron, and you can change the color of the sphere by throwing it up. And effectively, if you think about the 4 dots on the surface of one of these, in between them are 4 triangles. And he figured out a mechanism. We can cut one of these open. There's a gearing mechanism inside that's hidden from the public, where you get a dot.
Hold that up so they could see it, so the audience could see it.
So as you pull this thing apart, it can change colors.
Yeah. If you spin it ever so slightly, Joe.
Oh, wow.
Yeah? All right, that's for
nuts.
you guys. It's cool, right?
Yeah.
That's very bizarre.
All right, now my point is that one of the things that Terrence has going against him is people are saying, oh, he's just playing with stuff people have played with since antiquity. There's nothing new. And then I would say, well, and then why did Charles Haberman create a mechanism realizing the self-duality of the tetrahedron? Nobody even talks about it that way. And by the way, here's something that people, play Dungeons and Dragons, they don't really even have any idea of, is if you take the 5 Platonic solids here, and you put the tetrahedron in the middle, and you put the triangular structures of the octahedron and the icosahedron off to the sides, there's a duality that interchanges the pairs with the center being self-dual. In other words, the cube has 6 faces and 8 vertices. The octahedron has 8 faces and 6 vertices. The dodecahedron, 12 faces, 20 vertices. The icosahedron, 20 faces, 12 vertices. They all these pairs have the same number of sides because the number of vertices plus the number of faces minus the number of edges has to equal 2 for anything that is spherical in nature.
Now, if all of my things, when they come together, if they create a natural dodecahedron and they create a natural icosahedron, what does that say?
They do and they don't.
They do. No, I'm going to show you. No, I'm saying you haven't seen yet. I haven't shown you yet. But they will when you see it.
So,
why don't you show it to him right now? We're on it right now. Show it to him right now. Shout out to all the homies right now trying to figure out what the fuck's going on. Like, what are these guys talking about? Holy shit.
Legalize Schedule 1.
So you'll understand. And then I'll have to explain.
So we can't hear you, Terrence. You're not on camera right now, unfortunately.
I'm speaking to myself right now.
Right.
I'm speaking to myself right now, but
The problem is it's in the middle of a podcast.
properly. You're lucky to get it.
How's the family?
Everything's great, man. How you doing?
Saw your dog. I've met Marshall for the first time.
Oh, that's right. You never met him before. Yeah, he's the best.
He's a lovable guy.
Him and Carl, they were getting after it. Is Carl worn out? Oh, yeah. Oh, he's done.
Yeah, I wore Carl out.
Everybody wore Carl out.
So
here we are. I'm going to first.
Terrence, no one can hear you.
I know you.
I
can.
know, but we have a podcast going on right
Yes,
now.
we're about to put the headphones back on.
Okay, here we go.
Right here next to it.
The problem is you were talking off in the distance, and I can't even hear you. And I'm right here.
So this is where, if you'll go to where the 12 bubbles meet
yeah.
on the thing. So these, Joe.
Okay.
May I finish my riff on those toys before we get to these toys?
Sure.
My point was that I call bullshit on the idea that because Terrence is playing with stuff that people have been playing with since antiquity, that you can't come up, that there's nothing new under the sun.
Right.
Because if there's nothing new under the sun, first of all, how did Charles Haberman come up with something so cool? Second of all, that means that there's an object that hasn't been invented. I give this to high school kids. You should be able to throw one of these up as a cube and have it come back as an octahedron. You should come up with a gearing mechanism. And you should be able to throw up a dodecahedron and have it come back in your hand as a differently colored icosahedron. And I've never seen those toys. Just the way the Rubik's Cube came out of nowhere, or Hungary, and that thing took over the world by storm. So to claim that a guy can't do engineering on Platonic solids and come up with something new, the Rubik's Cube, the Haberman's switch pitch, these things prove that that's not true.
I think it's a foolish thing almost always to pretend there's nothing new under the sun. You should always consider it.
Well,
You might not be correct, but there's only one way to find
Well,
out.
there's a difference between, you see, Terrence has much greater odds of contributing to the world of engineering than he does to the world of mathematics. I mean,
Joe's got the right perspective. I don't think he's came across my research. Holy shit, when he does. Oh, shit. He might just be able to understand it, unlike a lot of scientists I've reached out to that haven't done the legwork. The thought work. No, maybe not legwork. That's maybe.
the odds that he's doing something new in mathematics, I'll be blunt, are very, very small.
Even though I have patents on it that shows that all of this is
I don't want to go there. The patents do not speak to what you think that they speak to.
That's okay.
And look, you can see into my heart. I'm not trying to.
No.
All right.
But
Thank you. You're like, hold the fucking phone with these patents, bro.
we were talking. I told you that we produce a supersymmetrical structure.
When you say supersymmetry, I don't know that you know what a supersymmetry is.
What does supersymmetry mean to you, Terrence?
Supersymmetry means that all things come together, fit together, relate to each other. They're self-referential, and they are from a fractal that comes back to that same fractal space. That's supersymmetry.
So what you mean is a symmetry that is amped up, but supersymmetry is a reserved term that means something hyper-particular.
And that's what this
between
is.
bosons and fermions.
That's what this is. This is the bosons. For the layman out there, the boson, the cloud, the whole boson thing is the force field or the energy field. That the fermions is considered the matter aspects of it.
So if we can go into he's got 5 of these patterns, one of which he calls the.
But what is wrong with the term supersymmetry?
Then I want to see an algebra, which is a linear vector space, which has an object called a bracket, and I want to see that bracket obeys a super Jacobi identity, and otherwise there's no supersymmetry.
But
So it's a specifically used scientific term.
It's a
and he's using it
reserved term of
incorrectly.
art.
Yeah, but it's geometry is its own proof. Supersymmetry and geometry allows you to visualize, like you look at the ocean and you see the supersymmetry associated with it.
I think what he's saying is you're talking about a thing and you're using the term supersymmetry, and he's saying that supersymmetry only applies to a very specific thing.
Because in their
That's been
math,
defined.
no, in their math, the Platonic solids, like I said before, have a discrete symmetry. You can only line up the blocks and all of those things. You can't put all of them together and tell a full story to where they fold into each other.
I don't think he's disagreeing with you with that. I think he's disagreeing that term
You're
that
using
you're
a
using.
reserved term of art,
Okay.
and you're using it incorrectly.
That's what
and,
he's
and
saying.
you're going to pay a penalty. In which
Okay, I don't want to pay no penalties.
Like, this is a
I got
thing
enough
where,
taxes.
like, if I'm watching an MMA fight and someone's doing commentary and they call a kick wrong, I'm
Right.
like, why are you doing this? You don't even know what that is. Like, you incorrectly reference something that's very specific that we've been talking about for a long time.
if you're if you're getting intimate with your lady and you're into rough play and she's not wearing any clothes, is it a rear naked choke if she grabs you from behind? No, a rear naked choke is a particular move.
Yes,
It doesn't
very
have anything to
particular.
do with what she did.
Right.
So is there
Unless she gets the hooks in.
That's a good analogy.
question in the world of physics, in the world of
Yeah.
mathematics, is there a supersymmetrical system, geometric system, ever been produced in mathematics?
Yes, in mathematics, yes.
What
We've
is
never
it?
seen super Poincare algebra.
Yeah, but that's on a plane. That's not volumetrically. That doesn't scale up.
Terrence, you have an entire way of thinking that is completely foreign to everyone that I know, and I've tried to understand what it is.
Oh, I'm sorry.
No, it's not a
No,
question.
it's not,
of
I
that.
don't think he's saying this is a
No,
negative.
no. I didn't see it as a negative. But
What I'm trying to say is, if the reason that science works as well as it does is that up until very recently, there were clear rules, cultures. We agreed to leave certain things that are at the door, like our religious beliefs. We agreed to submit to certain sorts of things. We were decent to each other. And that system is in a process of collapse at the moment. All right? Now, Terrence comes from an earlier way of thinking, when things were much more wide open. You don't find many polymaths anywhere in a respectable position anymore. Terrence is coming from a polymathic perspective. He's all over the map in terms of the quality of his thinking. As far as I understand, some of his stuff is really, really good. Some of his stuff is offensive, and it's everything in between. Now, I'm not gunning for you.
No. I don't take that offensively.
Okay.
I take it in the fact that you're here. But let's get back to what I was saying about having, if my pieces naturally come together and form those same
do and they
structure.
don't.
Well, here we have.
How do they not, Eric?
I'm going to show him. Here's where 12 bubbles meet. If you go to the yellow one right there, Jamie, please tap on that. This is where the negative space where 12 bubbles meet. I call this the Aubryon. I named it after my oldest daughter.
Okay.
You can take a look at it, at how it behaves. Here, Joe.
Okay.
So you can have it, and you can have a larger one or a smaller one.
By the way, I would be honored to
I'm
have
gonna give you some of these pieces.
anything that you make of this type in my home. It's very, very cool.
So when I put 10 of them together, they look like this.
Yeah.
I put 20 of them together, they make a natural icosahedron.
Yeah.
Without breaking any rules. I'm saying that the
I believe in this. This I don't disbelieve. I haven't gone through the math, but I don't disbelieve this.
I said the same thing about one other thing. So here's the light unit. If you'll go back to the green, Jamie, please. This is the light unit.
Now we're going to get into some stuff that's not going to be so much fun, but it is going to be, you are going to get what you want.
No, you're going to love this. You're going to love this because what I'm going to show you, as I said, and what you said concerning.
Now look at that.
Let's bring
Put it down, and it'll show you. This is where I've put 20 of them together. The same way I put 20 of these together, and it makes a natural dodecahedron. But what it's showing you is where electricity is being pushed into the center, and you'll see these magnetic waves coming out. It's showing you the magnetic field. So these predict and create a natural dodecahedron, whereas these come together and create a natural icosahedron. That's not something that just happens by accident.
No, this isn't an accident.
I'll put it up.
What's going on, Terrence, for me?
Can you connect all these together in one big ball of fury?
Yes, they just keep getting, because it's supersymmetry.
Yeah.
They all fit
I
together.
want to see
That's
these
what
and
I'm
these
saying.
together.
It ain't supersymmetry, but it's freaking cool.
Right. I know what you're saying. the
But-
problem is that term, right?
Well,
It keeps using
again,
that term.
my point is that you can run into all kinds of terms of art in a field that you don't know well.
Right.
And Terrence is, like, I come on your show and I do this thing, which I've never really discussed why I do it. I have this feeling that somehow Sean Carroll, 15 years ago, started talking about a suite of ideas, like entanglement, the multiverse, these Boltzmann brains, whatever. And people have been talking about them ever since because it was a very successful tour. Much of the coolest stuff in mathematics and physics that's completely established, that's non-speculative, is not discussed, and I don't know why. And one of the things I tried to do is I tried to show you the Hopf vibration. I tried to do the thing about the Dirac string trick. Terrence is bringing cool stuff from the world of geometry. It's a proof, effectively, that people don't know where it's coming from. A lot of this is real as geometry. If you look at the thing that he calls the Terrenton, right?
The tetrian is a
tetrian.
The tetrian is
Okay,
just
so
a
the
tip.
tetrian that is the thing that is closest to us, the black thing that is closest to us.
That one.
So he then starts to make noises about it, and he says things that I don't love, which are that those faces he associates with the electric field, and the vertices, which sometimes he calls vortices, and sometimes I'm not quite sure, he associates with the magnetic field.
Yes.
Now, I don't have a clue why he says the next thing, which is, and because the number of magnetic and the number of electric things are balanced, they cancel out, and therefore it's the weak force. And to me, it's just like super cool stuff, and then suddenly turns into horseshit.
But listen why. Here we have those two tetrians on the end. They both have equal poles, 4 electric poles and 4 magnetic poles, according to how I see it. Where magnetism is spinning off of the tips, the vortices, because it's no longer able to maintain that center space of spinning centripetally.
I don't know what the hell you're talking about.
Yeah, what brought you to that conclusion?
With what?
The way you're describing the energy involved in this.
Well, anytime you look at electricity, that was one of the things that Victor Schauberger was talking about. Electricity it's when water starts to spin to the right, it cools down. That's the natural nature of electricity. Electricity is colder. It flows better in the coldest environment. So those as it's cooling down, as it's spinning down to a higher point, trying to get to that higher point, that's the highest point there. It's looking for the highest density. That's the north. North is always the highest density. South, no matter where you are, south is always away from the higher point when you're talking about universally, not talking about geographically on the earth. North is always seeking a higher position. South is always seeking a lower position. That's based upon stuff that Walter Russell talked about, based upon the stuff that Victor Schauberger talked about. But it's a problem with the definition of the words, the terms.
Right, but your description of electromagnetic force and magnetism, like what is happening that it's bringing you to this conclusion that you're so specifically saying that something that you literally can't even see with the human eye is happening very clearly.
I'm saying 4 magnetic fields are pushing in on that area.
I don't see magnetic fields. I see those spheres.
Would be magnetism. What does magnetism do? It expands out.
What brings you to the conclusion
radiation.
that electric...
Well, let's say radiated field. Let me use the term radiated
Do you know what we think electricity and magnetism are?
You think that it's the same thing?
No.
Part of the same force. They have them coupled together.
Jamie, could I ask you to find a Faraday tensor?
Yeah, what I was trying to get to the conclusion, like magnetism and electricity, like what brings you to this definitive conclusion that you can so clearly state that this is what's happening there?
Well, based upon any time there's an electric force acting on something, it causes a cavity. Electricity is always pulling in from the inside. It's always trying to tighten the density.
And you assume this energy exists in the flower of life. Why?
Because that's where all those circles, the overlapping circles, they represent the magnetic field. They represent the radiative field that's coming out and coming back. Well, why does a bubble take the shape of a ball? Why not a square or a triangle? What's the why does it expand into a sphere?
A sphere is an abstraction that it's going to be the solution to many different problems. If I ask you to give me the maximum possible volume with the minimum possible area, I'm going to get a sphere. If I ask you what is the best thing to launch out of an old style cannon and to stack next to it, you're going to say a sphere. Then you have a question about, is that the same concept of a sphere? You know, if I take the three-dimensional sphere of unit quaternions, is that the same concept of a sphere? You are, in part, freely associating, repeatedly, between things that remind you of other things. Now, you have an incredible storehouse of things between your ears that you know to associate with. And your brain is like, I mean, in part, it's like, if you think about the totality of your brain, it's like a Ferrari engine and a Volkswagen. The Volkswagen chassis is not capable of supporting something else that you're doing really well. And so what you're constantly doing, as far as I can tell...
So the chassis being education, formal education.
It's not just that. I mean, it's in part... People who see many connections are often bad at cleaning up their own stuff. And people who don't see connections are often very rigorous and they don't do shit for their entire life, right?
See, that's why I love the geometry, because the geometry demonstrates, even though I've been autodidactic and have learned these things on my own, the geometry is its own proof. Like, even in showing that these become dodecahedron, that these create an icosahedron. If you'll move those just for a second.
Eric, you pulled this up, though, before we get any further away from that. Explain this, please. Electromagnetic tensor.
What you see, that F super mu nu is an anti-symmetric 4x4 matrix. That is, there are only 6 independent components, because if you flip that matrix from the northeast to the from the northwest to the southeast as the line in which you flip over with the zeros, the things above the zeros determine the things below. So there's 6 independent entries in the top triangle. Now, the top 3 are the electric components in a Cartesian coordinate system of the tensor, and the B fields are the magnetic. Okay. Terrence could say something closer to what we understand reality to be. He could, for example, hold up a cube and say, you know, the 6 faces of the cube remind me of the 6 independent entries in the electromagnetic field strength. And then the idea is there's a duality, and the duality relates the electric field to the magnetic field. And then he might invent something called Olive Montonen electromagnetic duality, right? So in other words, if I took the top 3, if I hold the cube up like this and I put electric above and magnetic below, and then I did a transformation that took top faces to bottom faces, he would be doing something that might bring him to recent research on electromagnetic duality. But instead, what's happening is that the spheres are reminding him of waves, like, you know, wave fronts that are expanding spherically. And he's got super cool geometry. The reason that this is so cool is that we haven't seen much of it. It's not saying that it doesn't exist. I'm not saying he's the inventor.
Well, I am the inventor because I own the patents to it.
But you can find out that there's prior art later. Look, everybody's been hurt.
I would love to see that.
Okay.
Like I said, though, I think
But Terrence, I have no desire to take this away. So far as I know, you're the first person to do this. Okay.
No.
Now, with that said, you're taking something where he's saying real stuff about geometrical understanding based on a spiritual undertaking. And it used to be that spirituality and science were hand in hand. That's what I was trying to say about the Carolus school that figured out, almost got calculus coming out of religious verse, like stuff that rhymed. It's crazy. Terrence is coming from an older perspective where he's drawing tons of inspiration from all these different sources. I can track it, but like, good luck finding people who can track this, because the number of people who can do this is very, very small.
But that's the problem. Okay, go
Agreed. Now, then every time he steps on a landmine, my colleagues just start laughing. And that makes me crazy, because they could help him figure out what he is trying to say. So if we go back to his
electromagnetic tensor, how does this apply to these patterns and the void in between these patterns?
That thing we did not understand until the mid-1970s. Remember I tried to tell you to get Jim Simons on this podcast and he just died? Jim Simons and C.N. Yang figured out, and this is going to figure into what Terrence is saying, that all forces are curvature. It's not just gravity, which we've known has been curvature since 1915, actually 1913 for Einstein-Grossman. It's actually the case that electromagnetism, the weak force and the strong force, are a different form of curvature, which might be called Arrhenian curvature or fiber bundle curvature, which is not necessarily Riemannian intrinsic curvature. This object encodes the curvature, it encodes electromagnetism as the components of curvature. To your point about nothing is a straight line.
But this is where I have issues. You're talking about this is in Cartesian space. And in Cartesian space, curvature is not allowed. There's no curvature that's allowed in Cartesian space.
That's wrong.
Really?
Yeah, because what you have, and by the way, this is a super subtle thing. We've only really known this for 50 years, thereabouts. There is a weird, mysterious circle that none of us can see at every point in space and time that we can't derive from space. Okay, you can have space-time, and something else put a circle at every point that is obscured from us. And that thing has a curvature, even if space and time is flat. So we call the idealization of flat space-time Minkowski space. You can slap a curvature tensor of a circle on top of it, generate this, and it wasn't until, and this is mind-blowing, can we get the Aronoff-Bohm effect up here?
See, but that's where my biggest issue is, why go through all of those steps to define curved space with flat plane matrix when you have the definition of it right in front of you? That's why when you get a chance, I'd love for you to lay these out so you can see it predicts every distribution, every waveform. There's nothing that this doesn't predict.
I want you to think about
Guys. Okay, that's a bad one there. Straight lines. Oh. Pardon me. I know it's not about shotograms. I'm just listening. Eric's making good points. Terrence is kind of rebutting them without reason, because it's kind of, he doesn't want to have to mend anything. He wants to just stand in the position he's in without any change, which is understandable, but at the same time, like, something's bound to be wrong if you've done enough of a model, and if you haven't, then what are we doing here?
You ever play blackjack?
I've never been good at blackjack.
Okay, well that's
never been
because
good.
you're sitting there.
I always overbet.
You're sitting.
Always overbet.
You overbet
17,
and you're sitting there on 19, and you say hit me, and all I hear is hit me on 19, and you keep going over.
Okay.
All right. Now, this thing here is a proof. This is a gift for you. This says we did not understand classical electromagnetism until the late 1950s, well after Mr. Maxwell. Now, what happened is we thought electromagnetism was that thing with the electromagnetic field components that we just saw. If you put a wire coming out of this plane of the screen and you insulate it where it says solenoid, can we just isolate that?
Mm-hmm. We can see it.
Yeah. Okay. Now you have this crazy thing, which is like you have a cathode ray tube at A, let's imagine, and you shoot it through a double slit And you want to know whether or not there's current flowing in this insulated thing that you can't see. Now, you think that the insulation is going to keep you from being able to tell whether there's current flowing. It turns out that the interference pattern changes whether there's current, even though there's no E and B fields outside of that insulated structure. And that proves that it cannot be the electromagnetic field strength that actually determines electromagnetic phenomena. What's really going on, can we call up the electromagnetic 4 potential? So one of the things is if you want to hang with the cool kids on any of this stuff, you don't try to map the electromagnetic fields because it's the electromagnetic 4 potential that's got it going on.
Look at that thing. That was cool as fuck.
I'm looking for something that looks like A equals and then 4 components. Well, let's hit that thing, what you just had. That's good. That A, where you see partial derivative of A, that thing is called the gauge potential. And the gauge potential...
It's a force potential.
The gauge potential is really where the electromagnetism is happening. This thing over here on the right, the Faraday tensor, is a consequence of the real star of the show. A is the thing that matters. And we thought that A was a convenience product that constructed the electromagnetic field strength until the late 1950s. I think one of these guys who developed this, his name is Yakir Aronoff, who's at Chapman University. I think he's still alive. So in other words, we fooled ourselves into thinking we understood electromagnetism until the late 1950s, which is one of the reasons that you listen to your heterodox colleagues as opposed to making fun of them mercilessly, because you're not nearly as smart as you think you are. Now, most of the time, what Neil says is, oh yes, 1 in 10,000 heterodox people have a point. And Neil bit.
Not just colleagues. I don't know if I mentioned this. I think I told the story, but I don't know if someone said they wouldn't look at my work, and I was like, okay, don't. You're not my peer anyway, because they was talking about peer review. I was like, okay, don't then. Not like you're my peer anyway, noob. Boom, headshot. Shit. Maybe there's a reason I haven't blown up and been recognized yet. I don't know what it could be. Oh, no idea.
Bets on the 9,999 who don't. And so he doesn't listen. This thing here is a proof that you can find elementary omissions very late in the game that change everything. And everybody who pretends that peer review works and that we've known this since antiquity, all this stuff, they need to understand the exceptions we've already found. If Terrence wants to do good, he would take that A with the new at the beginning, and he would say, okay, electromagnetism isn't about the electric and magnetic field. It's about 4 of these suckers rather than 6 of those.
On a simple level, how would you describe electricity?
Well, I wouldn't know how to do it simply. Electromagnetism is really about rock, paper, scissors. In other words, is rock better than paper? No, it's worse. Then you do it around that thing. The failure of these things to knit together. If I had, Terrence, give me your hands. I want to put my hand over yours, and then you
go your right hand.
Rock, paper, scissors is a good way to put like fire, air, water, earth, ether, alchemical elements. Interesting.
And under, it's like jujitsu. Go right hand under, on your hand, and I'll grab his wrist. There you go.
That thing. Who's on top?
All of us.
Okay, the electromagnetic field strength. So now make your hand into like a plane. Measures the degree of the Escher staircase. The Escherness in that Penrose staircase is measured by that E and B stuff. Okay? That A basically is the collection of hands that we had, the planes.
Right. Jamie, show the Penrose staircase just so people know what the fuck we're talking about, because it's a very bizarre optical illusion. There.
All right. So the key point is the Penrose staircase is not just an optical illusion. It's actually an effect called holonomy. And those things are called horizontal subspaces. And the electromagnetic potential, which gives rise to the photon, actually is a series of stairs that appears to be in some kind of a contradiction. The curvature that he keeps talking about is the thing that actually resolves that contradiction. And in a weird way, the photon is a function. I'm sorry, the photon is a derivative, and the electron is its function, and you use that derivative to differentiate the function. That's a crazy way of saying it, but at its deepest level, That's really what we are. We're in a geometry in which those flat planes say derivative equals 0. And you're trying to take the derivative of an electron based on this stuff. And geometrically, this only got worked out in Stony Brook, Massachusetts in the mid-1970s, except for a guy named Robert Herman, who nobody listened to in Boston, who was off self-publishing.
Well, let's consider one of the things that this is talking about. Again, this is where I have issues because we're talking about two-dimensional or three-dimensional space that does not exist. We're still talking about imaginary things instead of talking about real things like math's departure from where numbers started representing actual things. Math departed from that to where now math doesn't represent actual things. The numbers don't represent any true things. And so anything can happen inside the mathematics that they build from. But when you have the actual stuff, like what I wanted you to do, if you could lay these out just for...
I'm so worried I'm going to break these.
No, you're
things.
not. I made these over the last few days. Just lay them out. If you have to move those other things so you can see. And what I'm talking about, the interesting
I want to see a YouTube video of you in your lab putting these things together.
If you shine a light on these, they end up creating all of the cymatics. No, don't even stack them up. I don't even want you to stack them.
All right.
I just want you to align them.
Here, put a light to it.
Like I'm saying, if you move this one out of the way,
all right,
and some of those. This will continually predict every harmonic node, every wave function. It will continue on. They overlap on each other to where any size, any crystalline configuration that somebody could hope for occurs. This is the supersymmetry that I'm talking about that defines the entire wave field. This is one part of, this is the crystalline electric wave field. That's not even, that's just one of the
How cool is this? The problem that you're in right now is everything that you touch in this space made of spheres and platonic solids and whatever. You could spend your entire life, and I've seen people do it, staring into this and just finding cool thing after cool thing, thinking that you're seeing Jesus. I promise you, okay? I want you to hold this in your hand. This is made by a woman named Bathsheba Grossman. Pleasure to shout her out. She is a mathematical artist par excellence.
Shout out to Beth.
That is an 8-dimensional lattice called E8 projected into 3 dimensions, which is one of the craziest sort of sphere packing gadgets. This is ultimately maybe the weirdest object in the universe. It comes from a 248-dimensional group.
Let me show you this in real life.
No. Wait. You're gonna bob and riff and all this
Hold
stuff.
on, let him keep going.
And what I'm trying to get at is, look, I want you to think about this legitimately as a drug, okay? And if you're not very careful with the mathematics that you're playing with, you are going to get so high. You are going to see everything connect to everything. And there's a reason that this stuff takes place in Islamic art. There's a reason, if I bring up, this is another version of the self-duality of the tetrahedron. And I believe in sacred geometry, they call this the Merkaba, which is like Hebrew for chariot. Everything connects to everything else in this unbelievably beautiful way. And the concern that I have, Terrence, to be entirely honest, is you have to get disciplined about this as a drug, because otherwise you're going to see everything in everything all the time, and you're going to have the same repetitive conversation where people don't take you seriously because you're going to keep hitting on 19.
But if light passing through these show the same cymatics that we look at when we're looking at natural occurrences of individual frequencies, doesn't that become its own secondary proof beyond the symmetry of what it does?
You say geometry is a proof, and one of the things is you are at your weakest when you have an equal sign. No. You're your strongest geometrically. You're at your weakest when you have an equal sign. You say the dumbest stuff about equalities, and you say the coolest stuff about geometries. And I wonder whether you mean something. Like, it took me a long time to figure out what I think you mean when you do this riff on the square root of 2. Jamie, could I trouble you for that portal group /TH? Okay. If you do the square root of 2 challenge, right? You say, Howard's unbalanced equation. You say, okay, take the square root of 2. You cube it. That's equal to 2 times the square root of 2. That is illogical. It is unbalanced. It is unnatural. Now, at first, I had no idea what the hell you were doing. So I came up with something to prove to you that I'm trying to understand you. And I said, take the number of magi at Jesus' birth. He was born on the 25th day of the 12th month. If I raise the 12th root of 3 to the 25th power, and I take the fact that Jesus died in the 9th hour according to the Bible, I see the same Trinity rooted by the number of apostles. Now, that seems to be like a profound statement. But the fact is, all I really did is I created an equation based on two numbers, x and y. And your version of it, I put in 1 and square root of 2. And in mine, I used 12 and 3. And the reason I got 1225 is that 25 is just 2 times 12 plus 1. So in other words, the danger of this stuff, right, is that when you start to see patterns and you start to see stuff that looks crazy, you don't realize what you're actually doing. What you're really saying is you're coming from a perspective that is philosophical before it's scientific or mathematical. And you have a statement which says everything is in motion. And then you go into a riff about loops, and you say, take out your calculator, turn it to the side, take the square root of 2, cube it, take that
divided by 2.
Then you do this thing where you happen to know the large decimal expansion up to a point, which is increases people's confidence. You got to be worried because that's like the confidence in con man too. But you make a point. We have a name for the thing you call a loop. We call it a fixed point.
A fixed point.
A fixed point. Now, a fixed point, you have something called a transformation. The transformation, let me see if Jamie, if we can bring that back. So I'm just trying to standardize your, can we go below that? Let me see. Okay, Terrence loop. You have a mapping, T for Terrence, from the real numbers to the real numbers, given by x cubed divided by 2. If you take the polynomial y cubed minus 2y equals 0, that factors as y minus square root of 2 times y plus square root of 2 times y minus 0. You claim that there's only one number that satisfies a fixed point relationship according to that mapping, which you call a loop. There are actually 3, 0, negative square root of 2, and 2. You make the correct point that if you iterate that for numbers above the square root of 2, it's going to go off to infinity. If you were to go below numbers of square root of 2 but above 0, it'll go towards 0. 0 will go to 0. Mm-hmm. And then you have the same thing below negative square root of 2. It'll go off to negative infinity. And above square root of 2 but below 0, I think it'll go off to 0. Okay? That thing is studied under fixed point theory. And you can look up the Lefschetz fixed point theorem, the Kakutani fixed point theorem, the Brouwer fixed point theorem. All of these are proofs that you have to have fixed points. Now I thought, why does he keep doing this riff? And then I realized that he's got a thing about everything is in motion. So for him, it's unnatural and illogical, you use both words, that the square root of 2 would be fixed under this iterated experiment. Now, that is not unnatural. There's something, I hate to say it, it's called the hairy ball theorem. Can we bring up the hairy ball theorem?
Before you put your hairy balls on my pieces.
That was good. Okay, the hairy ball theorem says that you cannot comb the hair on a rambutan without creating a colic. So let's see if we have any cool images of it. In other words, if you have a map of the wind that is going along the surface of a sphere, there has to be some point which is perfectly still. If you have a map of a sphere to a sphere, there has to be some point that doesn't move. In other words, what you're saying about things can't be still is not only incorrect, it is impossible to avoid stillness. And this is in part what John Nash got his Nobel Award in economics for, because he took work of von Neumann and Morgenstern on two-person games, turned them into multi-person games with a higher dimensional fixed point theorem, and said a multi-person game is more interesting because that's a market, therefore markets have equilibria. So you're saying real stuff in a way that fundamentally just doesn't, we don't know how to talk your talk.
Then
but we
teach
know,
me.
Yeah, I know.
Teach me. I'm learning right now.
Okay.
But Jamie, do me a favor. Pull up the calculator. I want you to pull up the calculator. We're going to look at this loop. And you tell me that this loop isn't a contradiction and says that the math
Okay.
is... Yeah,
I want a scientific calculator. There we go.
Yep.
Okay.
Yep. Hit 2. Square root. It'll be over one more. I think that may be it. Yeah. Yep. Cube it. Hit x to the third. No. Go back. Go back. Yep. Hit 2. Square root. Cube it. Up. Right up there. Yep. Now divide by 2. Hit equal. Cube it again. X to the third. Divide by 2. That is a loop. Cube it again. Hit x to the third. That's an unnatural
Talk to me
equation.
about unnatural.
It's a loop. It's a tuck inside of the matrix. It does not allow
No.
for math to make
No.
sense because of the identity principle.
Okay, Eric.
You're trying to say something. What you're saying is wrong.
But what I'm seeing,
No. What you're saying is fine. I agree that you have a transformation that I called T. You can put those two steps together, which is cube and divide by 2. That thing is going to be dead still till the end of time. That's your point. And then you pass judgment on it. And you say that is not logical and it's irrational. And I don't know what you mean.
Well, because here we're multiplying something basically 3 times, and it's coming up to the same value as if we multiplied it by 2. And you keep doing that.
Yeah, well, I did that with
That's
the
a
12th root of 3, and I have a transform just like you.
But that 12th root of 3, that hypothetical situation you put up there, does not affect the rest of mathematics.
Sure it does.
That loop right there.
Is your point that there's something special about the square root of 2?
I'm saying that the square root of 2 is a manufactured number because of the identity principle. If the identity principle was not involved, then they wouldn't have a problem with 1 times 1 equaling 2.
Why are you offended by 1 times 1 equaling 1?
Just because action and reaction, the universe, it's the separation of math from science, when math was supposed to define physical.
That's a good question. Why are you offended by 1 times 1 equals 1? Well, because he always said because, man. He didn't deny it. Not offended. Oh no, I'm sorry to laugh. Hugs.
Things. So when they have things that doesn't align, we can't make sense. The rest of the audience don't understand. They're like, wait a minute, well.
Okay, objects in motion tend to remain in motion, right?
That was his first law.
But what do objects at rest do?
There's no object at rest.
So you have a problem with Mr. Newton.
There are no objects at rest because everything is sitting on something that's in motion. Everything is in motion within itself.
So this is like there's no straight lines in nature. So the idea is you're saying at some level that you don't believe. I mean,
that anything steals.
At a subatomic level.
That nothing steals because everything in the universe is connected. So if you have.
All things are relative, and then at some point it approaches stillness, where it's indistinguishable. Sure, it's on something moving and blah, 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 but whatever. Approaches stillness by growth, really. Big boy systems kind of hard to move. Tend to lose their momentum and just be still.
One still thing, then everything connected to it also has to be still.
If I understand what you're doing, and I try to steel man it, you're trying to say, look, first of all, the vacuum isn't a vacuum. It's roiling with activity, right? The void isn't a void. Stuff is happening. Virtual particles are coming in and out of existence. There is no vacuum, right? You're very much in tune with modern physics on that. You really are, okay? Then you have this idea of math is supposed to be about the physical world. It's not supposed to be unto itself. And if there is no vacuum, then there is nothing at rest because the vacuum is going to be in constant quantum tumult. And then you get to the point, which is something that is rest, therefore is unphysical, therefore it is unnatural. It took me a long time to figure out what the hell.
I'm literally saying there is nothing in the universe that is at rest because everything is moving and communicating through vibration. And vibration requires oscillation, and oscillation requires.
This is just Hermetic teaching. This is not new. As above, so below. Everything has rhythm, law of vibration, law of rhythm, law of principle of correspondence. Or I guess principle of rhythm. Whatever. But to focus on it, it's not really clear why.
Motion.
So what you're trying to say is that if the universe at its deepest level is a quantum mechanical system in which there is no ability to create vacuum in a naive sense, that the vacuum that we talk about is not the vacuum that people naively think, therefore any mathematics that references anything that is zero or still or whatever is invalid.
Is it imaginary? It's talking about an imaginary space.
Okay. I don't know what to tell you about this because if I say something about a sphere, you might say, hey, Eric, what is the thickness of your sphere? All the points, unit distance.
It's kind of deep now. It's kind of deep. It's kind of deep. Does nothing exist? Does nothing exist? It's kind of funny. He's saying zero doesn't exist. Let's go to my channel here. Assume nothing. No, really. Assume nothing. Like, let's say you were to do science. The scientific method begins with some assumption any way you slice it. And the least you can assume is nothing. So assume it. Assume nothing. I'm not saying, like, see how the meaning of this phrase, assume nothing, switches, like, completely when there's this, like, potential that it's a thing. Assume it. Okay, so nothing. We've assumed nothing to be. Like, there's nothing. Well, then nothing is all that is assumed. That's all that's assumed is nothing. Assume nothing, it's all that's assumed. Equal, opposite. Nothing, everything. It immediately, in its intrinsic nature, is like an eternal anode and cathode, equal and opposite to itself, giving birth to the universe. It just emerges from nothing. Infinity emerges. It's what the universe is the manifestation of infinity from nothing. So, sure, it doesn't, like, truly exist in a, like it's nothing, so it's really, like, nothing. It's not a thing. It doesn't exist. This, whatever it is that we call nothing, exists. And you should assume it, and then you will realize everything. Just from a mathematical standpoint. I know, like, people are like, what about God? Well, yeah, no shit. That's part of it all. All is part of all. Everything's connected. Reality is complex. I don't know what's going on sometimes, you know. What about God? What about God? Well, the market existed. The flood happened, so what about God? Well,
It's away from the origin. And I'd say, it has nothing. And you'd say, show me one thing in the universe that doesn't have thickness. And then I'd say, well, wait a second. I'm talking to you about a mathematical structure that exists as math. And you're like, I don't want it to hear about math that isn't immediately referenced to physics. First of all, that's not how this game goes.
When did math separate from accounting for physical things? Was the beginning of imaginary numbers?
The beginning of imagination. I mean, if I have a picture from AI of a woman that doesn't exist, but no, you can't tell the fact that was generated by an AI, are you going to say that graphics file doesn't exist? No, the graphics file exists. Mathematics has a physically independent structure. It is a system of logic. Then you have this very weird thing, which is, Eugene Wigner famously talked about the unreasonable effectiveness of mathematics in the physical sciences. But, David Tong, I think, talked about the unreasonable effectiveness of physics in the mathematical sciences. Many of us have had that for the last 50 years since Simons and Yang. And then there's also this thing which people associate with Max Tegmark, which is older, which is the mathematical universe, that the math is the basis, that there is a point at which the map becomes the territory, to borrow from our friends in the psychedelic community. Now, I can hear you, I can understand you, I can track you, but what you were doing when you were lecturing is terrible. It's really, really bad, because you have points, and by going over them and saying the super dramatic thing, you are in fact causing people who don't trust Tony Fauci, let's say, because Tony Fauci shouldn't be trusted, to say maybe we can't trust mathematics. Now, I have a lot of competitors, enemies, people I really don't like. I have stalkers who actually stalk my family and interfere in my personal life, who have PhDs, okay? My level of disagreement with them about the physical universe and the mathematical universe is essentially zero up to 1973. We don't really start to see a breakdown in the community of science, I think, until the 1980s.
And why is that?
Well, money. And power. Money and power. Ronald Reagan brought in a guy named Eric House to the NSF, and the university stopped expanding and they started playing games. We had a thing called the Mansfield Amendment, which got the military out of science, which was a disaster. There's a lot of things that happened. Okay?
But imagine if science took a wrong turn when it walked down the road of relativity.
Okay.
in abandoning the ether. And now they've walked down this road, and now they realize that it's a potential dead end. But instead of turning around and saying, okay, well, let's use the luminiferous ether that all of these equations were built off of. And here a young man that's outside of the world has come in and said, okay, I have the wave conjugations that make up and prove the etheric nature, the etheric substance.
So
that's what I want to,
Jamie,
we got to walk
if we
through
could bring back.
You need some evidence, dude. I have the thing I came up with that proves, like, it's standalone. You can't prove without the evidence, like, surrounding it. Like, see Hodgepodge et al. 2004, and whereas see what happens here, and blah blah blah, and see blah blah blah. Here's the 80 references I bother to consider worth pointing out to you guys because they matter to what I'm saying. No, just fucking I proved it on proof. Proofs take evidence. I've made thousands of discoveries. You gotta prove it, bro. You can't just say it without the proof. Is in the pudding, bro. Sorry, it's in the pudding, bro. It's in the pudding, bro. You had that pudding yet?
The portal group page, I can sort of show what Terrence is talking about, what his...
Okay, I'm at 2 hours in the podcast, so we're halfway. And the video's over 2 hours, so I'll stop here. And hopefully this will be less than 8 hours overall. Fuck. Thanks for watching. Hope this was whatever. If you made it, then I guess you liked it, or fell asleep, or walked away. Peace out.